Hello everyone and welcome to my YouTube channel. Today I'm going to create a kinematics design using an assembly that I generated in a previous video. So this is the assembly that I'm going to use, and if you want to know how we have created this assembly design, I suggest you to watch one of my previous videos where we put together all the parts. So today we are going to simulate the movement of rotating the handle and to see how these components are going to move. So in order to do that, let's go into kinematics. And here, as you see, we have a lot of constraints defined in the assembly. So as starting point, we can use all of them to create our mechanism. So we can go here and create a new mechanism. Let's call it mechanism 1. And if we choose auto create, okay, it should have created here all the joints. So you see these joints have been created taking into account the constraints that we have defined previously. So let's uh, understand more about the mechanism. So right now we have 4 degrees of freedom, so the mechanism is not ready to be simulated. So we can check it here. You see, mechanism can be simulated? No, right now. So let's improve that. So first thing that we need to do is find the constraint around the axis versus yeah, support, and it's a revolute, and this is going to be the constraint who will control the movement. So let's double click on it, and we can say that it's going to be angle driven. Okay, so now you see the degrees of freedom has been reduced to 3. So the other degree of freedom that we need to constrain is that when we inserted these pins, we didn't stop its rotation along its own axis. So this is the reason why we still have degrees of freedom. So the easiest way to fix that is try to find the pins constraints, so this one, and remove them. Oops, just 1 second. This one, remove them. This one, let's remove this as well. Yes, just 1 second. I think I am doing it wrongly. So what we want to do is that this pin, we want it to be, yeah. So we want it to be, let's say, rigid versus this part, and the red one versus this one. So if we remove this one, and there, this one, uh, this one, okay, and this one. And now we define a rigid connection, rigid joint between this part and this one. Okay. Another rigid between this one and this one. And now you see that the mechanism can be simulated. So let me just check part. I think that we need to remove this one as well. No, that's right. Yeah, so now the mechanism can be simulated. So now if we check again the status of the mechanism, we will notice that now we have here a yes, which means that we can start introducing the movement, which is going to be controlled by the rotation of this axis. So in order to do that, let's go to simulation, mechanism 1, and here is the command that is going to control the simulation. So you see, okay, there it is. Let's reset it 1 second because I think there is a problem with this pin. because it's not constrained. So let's find it. I think will be password 2. So this is rigid and this is rigid to the bottom part. Let me just check 1 second. We have this one 2.1, but we have not create 2.2 rigid constraint. So we need to create another rigid between this one and this one. Okay. And now when we do the same, so if we go to simulation mechanism, check this, you see now the pin is in place. Okay, so we know that it is working. Now we want to introduce a continuous movement. So in order to do that, we need to insert this command into our simulation. Just clicking here. With this arrow, we can control if we want just one lap or a constant movement. So let's make this so it will go from the lower limit into the upper limit and then go back. So it will rotate on both directions. Let's reduce also the speed of the simulation. Let's hide the constraints just to clean a little bit the screen. And now let's give movement. So you see how the system is working. Once it's achieved the upper limit, it will turn in the other direction. Also, we can change that. Uh, just let's pause it and just apply it always in the same direction. We will go always rotating in the same direction. So I hope that you have enjoyed this video tutorial where we have learned how to create a new mechanism. We have solved some issues about the degrees of freedom. So when you plan to create a mechanism, you can start it from zero, or if you have a proper assembly with all the constraints well defined, you can always import that constraints and it will create some of the joints by yourself. But if sometimes some of the joints are not created rightly and you have or you need to control all the degrees of freedom in order to be able to simulate the animation. So let's run it once more. And here it is. So if you have enjoyed this video tutorial, I will be waiting for reading your comments and also for looking at your thumbs up against this video. Okay, see you soon in another amazing video.